So next is content transfer encoding. This header defines the method used to encode the messages into zeros and ones for transport. There are 5 types of encoding methods that are listed in table 16.15. First is 7-bit. This is a 7-bit NVT SKY encoding. Although no special transformation is needed, the length of the line should not exceed 1000 characters. Next is 8-bit. This is 8-bit encoding. Non-SKY characters can be sent, but the length of the line still should not exceed 1000 characters. MIME does not do any encoding here. The underlying SMTP protocol must be able to transfer 8-bit non-ASCII characters. It is therefore non-recommended. Radix 64 encoded printable types are preferable. Next is binary. This is a 8-bit encoding. Non-ASCII characters can be sent and the length of the line can be exceed actually 1000 characters. MIME does not do any encoding here. The underlying SMTP protocol must be able to transfer binary data. It is therefore not recommended. Radix 64 encoded printable types are preferable. Next is Radix 64. This is the solution for sending data made of bytes when the highest bit is not necessarily 0. Radix 64 transforms this type of data to printable characters, which can then be sent as ASCII characters or any type of character set supported by the underlying mail transfer mechanism. Radix 64 divides the binary data made of streams of bits into 64-bit blocks. Each block is then divided into 4 sections, each made up of 6 bits. Each 6-bit section is interpreted as one character according to the given table 16.16. Next is quoted printable. Radix 64 is a redundant encoding scheme, that is 24 bits become 4 characters and eventually are sent as 32 bits. We have an overhead of 25%. If the data consists mostly of ASCII characters with a small non-ASCII portion, we can use quoted printable encoding. If a character is ASCII, it is sent as it is. If a character is not ASCII, it is sent as 3 characters. The first character is the equal sign. The next 2 characters are the hexadecimal representations of the byte. Figure 16.26 shows an example. Next is content ID. This header uniquely identifies the whole message in a multiple message environment. Next, content description. This header defines whether the body is image, audio or video. Now we will start with SMIME. So SMIME adds some new content types to include security services to MIME. All of these new types include the parameter application PKC7/MIME, in which PKCS defines public key cryptography specification. Cryptographic message syntax CMS to define how security services such as confidentiality or integrity can be added to MIME content types. SMIME has defined cryptographic message syntax CMS. The syntax in each case defines the exact encoding scheme for each content type. The following describe the type of message and different subtypes that are created from these messages. For details, the reader is transferred to RFC 3369 and 3370. Data content type. This is an arbitrary string. The object created is called data. Next is signed data content type. This type provides only integrity of data. It contains any type and 0 or more signature values. The encoded result is an object called signed data. Figure 16.27 shows the process of creating an object of this type. The following are the steps in the process. First, for each signer, a message digest is created from the content using the specific hash algorithm chosen by that signer. Second, each message digest is signed with the private key of the signer. Third, the content, signature values, certificates and algorithms are then collected to create the signed data object. Next is enveloped data content type. This type is used to provide privacy for the message. It contains any type and 0 or more encrypted keys and certificates. The encoded result is an object called enveloped data. Figure 16.28 shows the process of creating an object of this type. So the steps are: first, a pseudo-random session key is created for the symmetric key algorithms to be used. For each recipient, a copy of the session key is encrypted with the public key of each recipient. The content is encrypted using the defined algorithm and created session key. Fourth, the encrypted contents, encrypted session keys, algorithm used and certificates are encoded using Redx 64. Next content type is the digested data. This type is used to provide integrity for the message. The result is normally used as the content for the envelope data content type. The encoded result is an object called digested data. Figure 16.29 shows the process of creating an object of this type. First, a message digest is calculated from the content. Second, the message digest, the algorithm and the content are added together to create the digested data object. Next is authenticated data content type. This type is used to provide authentication of the data. The object is called authenticated data. Figure 16.30 shows the process. The first process is using a pseudo-random generator. A MAC key is generated for each recipient. Second step is the MAC key is encrypted with the public key of the recipient. Third step is a MAC key is created for the content. Fourth step is the content and the MAC, algorithms and other informations are collected together to form the authenticated data object. Next is cryptographic algorithms. MIME defines several cryptographic algorithms as shown in table 16.17. The term must means an absolute requirement. The term should means recommendation. So the first algorithm is content encryption algorithm. Sender must support triple DES. Receiver must support triple DES. and the receiver should support AES and RC2 or 40. Session key encryption algorithm. Sender must support RSA, receiver must support RSA, sender should support Diffie-Hellman and receiver should support Diffie-Hellman as well. Next is hash algorithm. Here sender must support SHA-1. Next is receiver must support SHA-1. Then sender should support RSA and receiver should support RSA. Next is message authentication algorithm. For this, HMAC with SHA-1 is required. Next, we can see an example 16.3. The following shows an example of an enveloped data in which a small message is encrypted using triple DES. So talking about the applications of SMIME, it is predicted that SMIME will become the industry choice to provide security for commercial email. In the example 16.3, we can see the content type as application/PKCS7 MIME. MIME type equals to envelope data. Next, content transfer encoding is Radix 64 as we have discussed before. Next, the content description is the attachment name called as the report.txt. So this is basically an example of an envelope data in which a small message is encrypted using a triple DES. This is all for the MIME and PGP securities. Thank you.